So, the graph of the function f defined by f of x equals negative half times x minus 4 squared plus 10 is shown in the xy plane above. If function g, not shown, which I have drawn in, and I actually have it drawn in incorrectly, so I'm going to show you a graph online in just a second. Because note the scale here is different than it is here. That's why this graph is tricky. So g of x equals negative x plus 10, which is what is one possible value of a such that f of a is equal to g of a? Well, first of all, got the problem written right here. And the next thing I want you to think about is it says f of a and g of a. This is kind of totally a distractor because who the heck cares that it's a? Why can't it just be f of x equal to g of x? So forget that. Just think about f of x and g of x. Now, before we do any algebra, because that's really what we need to do, not sure if this is a calculator problem or not, because if you have a graphing calculator, you can see where the line intersects the parabolic curve there. It intersects it at 2, 8, which you can see down there at the bottom is estimating that, but that's really what it is. And it's also right down here at A2. So let's click back over here and let's do the algebra. Because basically all they want you to do here are set these two things equal to each other. So we've got negative half times x minus 4 squared plus 10 equals negative x plus 10. So the first thing I see right away is that we can dump the tens. Goodbye, goodbye. So now we've got negative half times, and I'm going to go ahead and multiply x minus 4 times x minus 4. That's x squared minus 8x plus 16 equals the negative x. Next thing I'm going to do is I'm going to get rid of this negative half. How do I get rid of this negative half? I multiply both sides by negative 2, which cancel, now gives me x squared minus 8x plus 16 equals positive 2x. Now, I was trying to think if there might be some shortcut. I can't really think of any other shortcut for this problem other than just straight up doing the algebra. And this probably is like a, I think they have level 4, level 3, or level 4 problems for SAT. This is going to be a higher level problem because you've got to do the algebra. From here, you realize that it's just a quadratic and you need to set it equal to 0. So that's x squared, and if we subtract the 2x from both sides, we get negative 10x plus 16. And quite frankly, from here, it's very easy to factor. Factors of 16 that add up to negative 10 are x minus 8 and x minus 2, which is why your answers are 8 or 2. Because remember, it said, what is one possible value of a? Well, there's one possible value of a, 8 or 2. All right, this next one. In triangle RST above, point W, which is not shown, lies on RT. So it can be anywhere. So what is the value of the cosine of angle RSW minus the sine of angle WST? So I've already got this picture drawn right beside it, so I really don't even need to do it again here. And quite frankly, one thing that might be a distractor is that if you have a right triangle and you see 5 and 12, the unknown side is 13. But it doesn't matter because this problem, you have to know trigonometry and you have to understand the whole idea of cofunction identities. So I mean, I can explain it to you what's going on here, but if you don't know what cofunction identities are, this isn't going to make a whole lot of sense. So first thing I did here is I've just put W anywhere, and it doesn't matter where it is. It might even make a little bit more sense if we drop it straight down and we make a right angle out of it. We could even put it there, but it still doesn't matter. Because if we look at it as the fact that this is a right angle up on the top, therefore the two angles RSW and WST, they are going to have a sum of 90, which means the cosine of x and then the sine of 90 minus x. And of course, if you know cofunction identities, you know that sine of 90 minus x is the same as cosine x. What we end up with here is cosine x minus cosine x, which is 0. But the key to this problem is realizing that these angles are complementary. They have a sum of 90, and regardless of how big they are, this much information is going to be true. That's all based on cofunction identities, so the whole thing is just equal to 0. So in this problem it says the range of the polynomial function f is the set of real numbers. Here's what's critical: less than or equal to 4. Less than or equal to 4. When it says the range is less than or equal to something, it means that this parabola is going to be opening down. It means the parabola is going to open down when it says less than or equal to 4. If the zeros of f are -3 and -1, we're going to have zeros at -3 and +1. We gotta look at these graphs and figure out which one it is. All right, so first of all, if we know that it's going to open down, then that immediately takes away letter C. It also tells us that if the range is less than or equal to 4, it can't be D down here on the bottom. So if it's not C and it's not D, it's either A or B. So let's check it out. Which one has zeros at -3 and +1? -3, +1, there you go. It's got to be A. That is a reading comprehension question. That basically has not a whole lot of math that needs to be done behind it. You've got to read it carefully and you have to look at the givens.